The impossible dig. Engineering the Channel Tunnel. The wall of water. The busiest shipping lane on the planet. 22 miles of freezing, unforgiving water separating a continent from an island. For over 200 years, it was a geopolitical dream and an engineering nightmare. The first plan dates back to 1802, an era of horses and oil lamps. They tried to dig in 1880, but the sea always wins. Until two nations decided to take the ultimate risk. This wasn't just about digging a hole. It was about fusing two economies through a layer of rock 75 meters below the waves. Today, we're looking at the mechanical grit and impossible precision behind the Channel Tunnel. The geological needle. The biggest enemy wasn't the water, it was the geology. To succeed, engineers had to stay within a very specific layer, the chalk marl. The math. They were aiming for a vein only 20 meters thick. If the cutters drifted too high, they'd hit porous, fractured rock, leading to a catastrophic flood. Drift too low, and the sticky clay would seize the machines like a vice. It was a 39-kilometer game of operation, played with 1,000-ton machines. The Subterranean giants. To conquer the chalk, they didn't just buy tools, they manufactured monsters. 11 tunnel boring machines, TBMs. Each one was a self-contained subterranean factory nearly 200 meters long. The UK side. At the cliffs of Dover, they dynamited 250,000 cubic meters of rock just to create a launch pad. The French side. They dug a massive, 60-meter deep circular pit at Sangadi. Inside these unventilated tunnels, temperatures spiked to 50 degrees Celsius. It was a pressure cooker miles from the sun. Every meter was a gamble. Every drop of seepage was a warning. Breakthrough. The handshake. Two separate worlds were drilling blindly toward a common point. They relied on gyroscopes and laser guidance. Any error, even by a fraction of a degree, and they would miss each other entirely, leaving two dead-end pipes beneath the sea. On December 1st, 1990, the world watched. The first pilot hole broke through. The alignment error? Less than 50 centimeters, 39 kilometers apart, 75 meters down. That is impossible precision. But what happened to the machines? The UK TBMs were too massive to turn around. In a final act of engineering sacrifice, they steered the machines downward, buried them in the strata, and sealed them in concrete. They are still there today. 6 English giants, entombed forever beneath the channel. The cost of connection. The engineering was a miracle, but the finances were a disaster. Costs ballooned from £4.7 billion to over £9.5 billion. And the human cost was real. 11 lives lost to the chalk and the machines. But the design proved its worth. With 3 separate tunnels, 2 for rail and 1 for service, the system was built for the worst-case scenario. When fire broke out in 1996, the service tunnel became a pressurized sanctuary, saving every soul on board. Beyond the barrier today, London to Paris is a 2-hour sprint. The wall of water has been conquered by a permanent bond of steel and chalk. The Channel Tunnel remains a testament to what happens when human ingenuity refuses to accept impossible as an answer. The next great connection is already on the horizon. Are we ready for it? I'm Subject Zero. Thanks for watching. Don't miss what's next. Subscribe.